easiest way to remember these is to say that a dependent variable depends on something, okay? And an independent variable might be something you can't really control, like a person's height. They're going to just be the height that they are. Or it could be something that you are controlling. For example, you might want to see whether more sunlight affects the growth of plants. And so the thing that you're going to control is how much sunlight they get. Okay, you're in control of that. Whereas something like how much the plant has grown, well, that's going to depend, isn't it, on how much sun they got. So if you are graphing how much sun a plant receives to compare it to how much it grew, you would put the independent variable, which is the thing you get to control, on the x-axis, okay? And the dependent variable, which is how much the plant would have grown, generally goes on the y-axis. Now, sometimes you'll want to graph two variables that are actually independent, and you can do that by putting one on the x-axis and one on the y. Now, what happens once you graph a bunch of pairs of numbers? Now, when I say pairs, each one of these points on a scatter plot is just a coordinate pair. So you could think of it as a pair of x and y values, but remember, you're not necessarily graphing x's and y's. You might be graphing height compared to weight, or you might be graphing height compared to arm span, something like that. So you'll have measured someone's height, a bunch of people's heights and a bunch of people's weights, and then you'll go ahead and graph each pair to see if they line up to make something of a relationship. Now, no correlation in the data looks like this. It looks literally like a scatter plot. Everything's scattered everywhere, and there's really no rhyme or reason to it. Whereas, if you have a positive correlation, all of these are positive correlations, what you find with a positive correlation is that as one variable increases, so does the other, okay? So that means as the x values get bigger, the y values also get bigger, and you get something of a relationship going up like this. Now, how strong the correlation is, well, that depends on how tightly the data is grouped. So a perfect positive correlation has all the data in a perfect straight line. Now, you could rule a line through this, and it would allow you to then predict if someone gave you a value for the x-axis, you could almost definitely predict what value would match it on the y-axis. A strong positive correlation means that the data is pretty tightly grouped. It's not perfect, but there's a really tight cluster there. And then a moderate correlation, it will be a little bit more spread out. And a weak correlation is there, but obviously a lot more spread out.